Good afternoon. My name is Farokhnejad, a PhD student of University Grenoble Alpha in the League Lab. I am talking on behalf of my co-authors Raj Ras from Birla Institute of Technology in India and Javier Espinoza from University Lyon 2. I'm glad to present our work that we have done on classifying macrotext document dataset for assisting data consumers to rewrite their query using a classified vocabulary derived from top-K results. Our work is motivated by a real requirement that emerges in disasters. With the emergence of social media platforms, see number one, during a disaster, people produce posts notifying about events happening during a disaster and about relief actions provided by volunteers willing to provide relief. Exploring this data, it can be possible to reduce disaster response delay under the condition that information is correctly classified. So number two, due to the huge amount of posts produced in very short time, the challenge for casualty and volunteers is to figure out which help calls posted in social media have been addressed. For example, people needing water in some area and some point, and which need to be taken care of or not. For example, water has been delivered in response to this call. In this sense, the research question that guided our work was how can social media posts be efficiently explored for identifying the events like help calls that happen during this crisis and related relief actions. Our response is to propose a query expansion solution for exploring microbilliard collections. The solution is based on hypothesis that exploring microbilliards can be expressed as a classification problem, and therefore our proposal is based on a pipeline using classification models. Now, let's dive deeper and have a look at our approach. Query expansion is the process of rewriting conjunctive and disjunctive keyword-based queries by adding terms to increase the possibility of exploring the most number of items in a collection. For example, see number one. A volunteer can be looking for macrotext in Twitter about damaged buildings. Yet, as seen in number two, the person might not get tweet talking about damaged houses, schools, churches, neither post talking about destroyed buildings or areas, which can be also interesting when people want to provide relief. In our approach, we rely on a curated set of microbilliards represented through several data structures classically used in information retrieval solutions like inverted indexes and frequency matrix in number 4. Besides, the microbilliards have been already classified with classes related to crisis vocabulary, and then as those related to events and relief action as shown in number 3. Given this curated microbilliard dataset, queries are pre-processed and also classified to determine whether they are related to events or actions, as you can see in number 4. And by exploiting data structures representing the content of dataset, we look for terms close to those used by initial query in order to expand it. So, in our example, damaged buildings can be expanded with terms like house, severely, quake, etc. shown near the image of our frequency matrix. So, as you can guess, classification for both microbilliard dataset preparation and query expansion is the backbone. So, the challenge is to look for the best classification model that can ensure that query expansion will lead to queries that will potentially touch all the tweet talking about its initial keyword. Let us see how did we choose the right classification model. The question to answer were What is the best classification model that can further and best classify the tweets into event and action classes? And the second one is query expansion based on the best classification method effective to extract relevant keywords? To answer this question, we implemented an experiment pipeline described in the following slide. The classification pipeline consists of three steps. In step 1, created a baseline applying classic supervised learning model in number 1. And then in step 2, shown in number 2, see whether a convolutional neural network with no prior knowledge could do better than baseline model. Finally, in step 3, look for better classification result and test whether multitask deep neural network led to better results. We choose Google Colab to run our experiments. Our experiment used Twitter data of 4 crises from the crisis NLP dataset. The complete comparative evaluation of classification model on a crisis tweet dataset is shown in the figure. Two important observations. First, as you can see in the figure, among all the classic classifiers, the accuracy score of SVM is comparatively higher than naive Bayes and random forest. However, CNN model outperforms all of them. Second, as it highlighted in the table, MTDN outperform other models in terms of accuracy score. However, from computing complexity point of view, since CNN performance was very close to MTDNN, we can also use CNN instead of MTDNN, which will save computational power and cost. Once we found the right classification model using this experimental comparative approach, we propose an algorithm that implements our classification-based query expansion strategy. The algorithm consists of two main phases. The one that deals with query pre-processing that extracts terms to find related tweets. And the second phase is classifying the query to determine whether it can be classified as event or action, and rewrite it by expanding it with relevant related terms. For assessing expanded term quality, we have compared the performance of our proposed classification-based query expanding method against the traditional query expanding method. We calculated the mean average of cosine similarity between query and expanded query terms to assess performance of proposed approach. The experimental results show that the expanded query terms obtained from the classified query expansion model are more similar and relevant than the non-classification model. To conclude, we proposed a classification-based query expansion method. Based on our experiments, we observed that query expansion based on the classification method obtain better candidate expansion words, which are semantically close to the user query. Our future work concerns exploring more robust and advanced NLP models such as BERT. Thank you for your attention.